Hello, my name is Ronaldo Mock, and this is the Charged Tape Lab of Physics 2212. In the charged tape experiment, using Scotch tape, we are estimating the charges on each piece of tape while observing the transfer of electrons. We do this by using the following key concepts: Coulomb's law, Newton's second law, and Newton's third law. In the lab, we have found that the U-tape repels since they have the same charge. The tapes are positively charged. The charge on the tape is approximately 1.5 times 10 to the negative 8 coulombs. And the magnitude of excess charge is 6.63 times 10 to the 10th electrons. We did this by using the assumptions that we ignore air resistance, that the tapes are treated as a point charge, and that U-tapes have charge evenly distributed. In the first experiment, we saw that the U-tape 1 and the hands were attracted to each other, that the U-tape 1 and the table were attracted to each other. The U-tape 1 and the negatively charged pin were also attracted to each other, but that the U-tape 1 and the U-tape 2 were repelling against each other. We found that the tape strips were positively charged. In the floating tape experiment, to ensure that there was a more accurate calculation, I found an average of 0.033 meters between the tapes. I then calculated the magnitude of the gravitational force and equaled it to the electric force and I used that to solve for the charge Q on the tape, which I found to be 1.54 times 10 to the negative 8 coulombs. For the experiment calculations, we found that the number of electrons on tape B was 9.63 times 10 to the 10th electrons. For the number of atoms, we found that we used a ratio of tape to atom and found that there were 4 times 10 to the 17th atoms on the tape. And for the ratio of electrons to the atoms, we found that there were approximately 2.4 times 10 to the negative 7 electrons per atom on the tape. In the computational model, tape A is the blue sphere and tape B is the red sphere. The yellow arrow represents the electric field as a force vector, and the green arrow shows gravitational force as a vector. We can then see that the charge on the tape was 1.54 times 10 to the negative 8 coulombs, and that the number of electrons on the tape was approximately 9.63 times 10 to the 10th electrons. And we did this using GlowScript, which is a Python IDE, and my code is to the left. If protons had a negative charge and electrons had a positive charge, none of my observations would have changed, since the forces would have remained equal, or the interactions would have been practically the same, since the opposite charges would have still been attracted to each other, and the like charges would repel each other. It is important to handle the tapes as little as possible so that the charges on the tape would stay as intact as possible. If the charged tapes come into contact with hands or other objects, the charge could then be dispersed, and the tape would leave the positive charge it has. In other words, it would lose the positive charge that it has. Thanks.